ultimate face right there, Mr. Rose face, yes. So what we're going to be doing today with our math lesson, what they want you to be able to do is to solve multiplication. This is the focus that they have. It says solve multiplication problems with in which one factor is a decimal number. So we're continuing to work on what kind of problems today?
Story problems.
Multiplication problems. Thank you very much, Caden, for showing your hand. Really appreciate that. So multiplication problems. What's the difference though today? Instead of doing just regular multiplication problems, well, regular I should say, what kind of multiplication problems have we been doing? Let me go back. What have we been doing? Scott? 2-digit by 2-digit multiplication problems. So what are we going to be doing differently today from this?
You're going to be multiplying 2-digit decimal with 1 digit.
So, good, there's a lot of digits there. We've got, what this is saying is, one of the factors is going to be a decimal number. One of them is going to be a decimal number, not both of them. So instead of doing just a 2-digit multiplication problem by a 2-digit, 2-digit by 2-digit, we're going to do, one of the digits is going to be normal, the other digit is going to be a decimal number today. Okay, so changing things up just a little bit today. They have got us starting off with money, because money is a very great place to start off with decimals, right? We use money, we use decimals in numbers. When we're using decimals in with money, what are we showing? What's after the decimal?
Another dollar.
Okay, dollars actually are in a different spot. When we use decimals and money, what are we showing?
Cents.
Cents, good. That's that language. You guys all understand that? Yeah. After the decimal place, we have our cents with money. So it makes sense to talk about cents with decimals. We've got decimals and money situations. The Ruiz children had a yard sale, and again, you can go to Edmodo and follow along like Amadou is doing here. You can follow along with what we're doing. All the pages are there for you.
So, you didn't take a picture of
the Ruiz children had a yard sale. They sold some old toys. They made a table to show how many toys they sold and how much money they earned. What kind of a table do you mean? Do they mean one of those tables that you're like sitting at right now?
No.
What kind of a table are they talking about?
A multiplication table.
Okay, multiplication table. That can help us with facts, right? However, I think a table, I think I'm getting closer. Can someone else tell me a little bit more information about what a table is in math? It's actually, it's right up there on the page.
A table shows like what you're going to sell and then how much money you're going to sell it. And then like see like if you have 9 cents and then you got 3 times.
Oh, so you're saying it presents information?
Yes.
So it's showing information. It's just a way of showing information. Okay, now let me just be really clear, because John David and Gideon, you guys are right. Graphs do show data also. However, is this a graph right here? This actually is a data, or this is a table, excuse me. This is a table and it shows data. However, it's not a graph. We can make graphs out of this though. So they're using a table. This is the table they're talking about. Number of items that they sold here, or the number of items, and we have the price of them, and then we have the total amount of money that they earned in cents, and the total amount that they earned in dollars. Really quickly, a little review. I'm just going to ask you, because most of you are in either Notability or something, go to a blank spot in Notability. Really quickly, 9 cents right here. 9 cents. Will you write up the decimal for that? Keep it to yourself. Write it really quickly so I can see it. I also see 0.9, and I also see 0.09. A lot of different answers. Oh, I also see this. 9 cents. Someone being tricky about throwing the cent sign in. A lot of different things here. I see almost every option. Which one of these is 9 cents? Do you know? Yeah.
No, I don't know.
I think I know.
I know. Okay, that's good. I know you guys are getting so pumped about math, and I love that. This is 9. This right here, if it's in front of the decimal place, this is actually where dollars occur. This is the ones place. So this is actually $9 right here.
What?
Okay, that's $9. All right, can you understand that? That's the ones place. If we go into this place value, one place value after the decimal, this is the tenths place value. This is actually 90 cents. This is 90 cents. This is the hundredth place value. This is 9 cents here. Okay? With a decimal, this is the appropriate way to show it. Somebody was trying to be tricky. This is another way of showing 9 cents. Okay? Another way of showing 9 cents. However, there's no decimal there. I wanted to specifically understand what your decimal. Show me your iPad. 3, 2, 1.
I know it's dark.
As you can tell, I'm trying to stand on purpose right here in front of something that is there. Good, I see most of you have written up 27 cents.
Yes.
Now the appropriate way also would be, get a zoom in here. The appropriate way would be to show that there's a 0 in front of that 27 cents. Okay? Really important to understand that. I didn't go over that very well before. However, this is what the problem would look like. 3 jump ropes times 9 cents equals 27 cents. Now this is really weird because look at this right here. 3 times 9, they put 27 cents like Caden kind of showed it. And that's a whole number right there. There's no decimal there. However, when we start adding this decimal in over here and our answer looks like this, what do you think how on earth did they get the 27 cents to look like that? Will you talk about that at your table? Talk about how you think that they got the problem to look like this. Because we're multiplying a whole number by a decimal, and then our answer is a decimal.
Because it's just like
Talk about it. Yeah, go ahead.
it's just like 3 times 9, but without the zeros. It's like 3 without the decimal, without the zeros. Like 3 times 9. You're adding the decimal 9 3 times itself. So we stay decimal because it wouldn't transfer over. It wouldn't go over 100.
Decimal in this problem here. What's the similarity that you saw?
It's in the same place as the other one.
Oh my gosh, so there's 2 decimal places here, and so in our answer there's also 2 decimal places. Do you see that? Right? We start out with a 9 in the hundredth place value here, and our answer, ends with a 7 it ends in the hundredth place value too. There's 2 decimal places in both of these right here. That's really important.
There's like a decimal in the beginning at the end of the problem.
So let's go back and look at 3 times 9 cents. You said that there's a decimal in the beginning right here, correct?
Yeah.
Right where we're looking at up there, the 9 cents.
Mm-hmm.
And then we also have the decimal places, the same amount of decimal places in our answer. So there are, how many decimal places with the 9 cents? How many decimal places are there?
2.
There's 2. There's a 0 after the decimal place, or there's a 0 after the decimal, and there's also a 9. So there's 2 there. How many decimal places do we have in our answer also?
2.
2. Look at that similarity right there. Because there are 2 decimal places before the equal sign, there will be 2 decimal places after the equal sign too. Okay? You kind of all understand what's going on here? Let's look at another problem down below. Mia, actually, you know what? I'm going to have somebody read that out loud for me. You want to read that out loud, Jacob? Go ahead.
Mia saves the change from her lunch money each day. She gets 34 cents in change, and she has been saving it for 26 days. Mia used the steps below to find out how much money she has saved so far.
All right. You know what I really think was awesome? He read that number up there on the board. He read this number right here really well. He ran into it, and he started to say, $1. Oh, you know what? That's not a dollar. How much is that?
34 cents.
34 cents. Great job changing and understanding how to read that number. That is a huge part. Number sense, being able to understand the numbers that you're looking at is very, very important. So we got 34 cents. She's getting 34 cents in change every day, and she's saving it for 26 days. Okay, 34 cents And we want to find out how much money she has saved up after 26 days. So, we've got a problem. The problem they have written up for you on that page looks like this. 34 cents times 26. What is the 26 that we see there? What is the 26? Yeah. 26 days. Very good. Look at what they did. Does anybody remember what strategy this is kind of like? Yeah.
The multiplication thing.
Yeah. Which strategy was that though with multiplication? Do you remember how we did that? You remember, Eli? You remember what it was called? There was a way that we broke the numbers apart and then we multiplied them by each other. That was one of the strategies. Do any of you use it? Some of you might have tried using it.
Expanded notation method?
Expanded notation method, yes. Nice job. That's exactly what this is called. The expanded notation method. We have 30 cents expanded, and then we also have 4 cents expanded. That's what they did there. And then they also did 20 days and the 6 days. They expanded the entire thing. So let's take a look at these steps. Step 1, oh my gosh, what is that called again, where we've got all this data here in a organized fashion? What's it called?
A chart?
Close.
A table.
A table. There's the table. So we've got a table of information there. Step 1, multiply the number in the ones place, the 6, multiply by the number in the ones place. Excuse me. So they're going to multiply by the number in the ones place. As you can see, we've got 6. Whoop, sorry, zoom back in there. We have 6, and it is being multiplied by 4 cents up there in the first part. Okay, that first section, 6 multiplied by 4 cents. Then underneath that, they have done 6 multiplied by 30 cents. And they have also put the answers up there. 6 multiplied by 4 cents, what was their answer? As you can all see, what do you see? Melanie, what did they do to get to their answer? 6 times 4 cents. 24 cents, you're absolutely right. 6 times 30 cents. What did they get for their answer there, Scott? 180 cents. So we have 2 different answers here. Pay attention to that. I'm going to circle those so we remember to look back at those. Oh, 600 cents. I'm not going to put 60. That wouldn't make any sense if I put 60. Can you add those up?
Yeah.
Go ahead, let's see you do it. Good, I got people working furiously. I can smell your brain cells just exploding right now. What did you come up with? How many cents did you come up with? Ooh, let's see. Let's see what you came up with. Very, very important to remember to keep all of your numbers in the correct spot. Right? Super important. I'm going to add them up really quickly. I'm actually not going to ask for all the answers. 8 plus 8 plus 2, that is going to be 16, 18. Okay, and then I'm going to carry a 1. I don't actually need to carry the 1 all the way up there, though. I'm going to put it right there. And then I've got 8.
8.
Oops, sorry. So I want to have 1 sign. So this little guy right here is not going to want to be on the other side over here. We're actually going to want to have only one of the signs. So we would want to get rid of one of them. Which one should I have? Should I have the cents or should I have the dollar?
Dollars. Dollar.
Why should it be the dollars?
Cents.
What do you think? If I keep on asking questions, will you just keep changing your answer?
No.
Yes.
No.
Yes, we will.
Are you sure it's dollars?
I'm sure.
I'm positive. I'm positive.
I'm absolutely positive.
I'm positive.
When we have a decimal and we are showing